So today we're taking a look at the final part of graphing polynomials. I know it's been a long section, but we needed all that background information to get to where we're at now. So with this, we are going to actually graph polynomial functions. We're going to do both from graphing from a given equation and graphing from given points of information, not the actual function, and being able to sketch a visual graph of it. All right, so to start, graphing polynomials, you want to keep a few things in mind. First, you want to be aware of what is the end behavior. And remember, we figure that out by looking at the degree and the leading coefficient. That will give us an idea of what's happening on both ends, on the left end and the right end of our graphs. Are they both pointing up? Are they both pointing down? Are they opposites? Things like that. So I put in some things to remember. Odd functions are going to be compared to linear graphs. So if it's a positive leading coefficient, one side, the left side, is pointing towards the negatives, and it's moving in an upward motion to the right side in the positives. A negative leading coefficient goes in the opposite direction. It's going downwards. So it's going to start high up in the positives on the left and move down to the negatives on the right. Even functions, you're going to compare to quadratics. So if it's positive, both ends will point up towards the positives. And if it's negative, both ends point down towards the negatives. Okay, we learned that back in previous sections. We're then going to just create a table of values. It's going to be easiest for us to do. -2 to +2, I consider the safe zone. It's going to include a y-intercept on there. Gives you some good variety of points. And then you just plot those points. Obviously, if something is way too big for your graph, you just will skip that point, but know that it's moving in the direction of wherever that value was. And you'll just estimate any decimal values that you might come up with. And then I have a note on the bottom. After you graph, you want to make sure, do the ends of your hand-sketched graph match what you made note of with your end behavior? So it's important that you do that because your last point might look like it's going in a downward motion, but in essence, because you knew that it was a positive leading coefficient, it should end going upright towards the positive. So you want to keep that in mind. Somewhere it would end up turning around. So we have a bunch of examples. I'm going to kind of quickly go through this first one. We'll do a lot more in class together. First, we have, excuse me, it is a negative leading coefficient, and it's an odd degree. So in my head, I know that it's going to start on the left side in the positives, and it's going to move in a downward motion. That's my end behavior that I'm keeping in mind. You put this in your calculator, excuse me, and you end up with the values 3, -4, -3, which I knew my y-intercept was that anyway from my function, and then 0 and -1. Right. Once I have those, I can plot all of them. So -2, 3 is up here, 1, -4, 0, -3, 1, 0, and 2, -1. Okay, so when I go to graph and connect these dots, I know I have to start up in the positives, and I see this is starting high. I tend to always start with my ends. I know this one has to go this way, and this end has to go this way. I have no idea till where or when, but I know the ends have to go up because we said that over here, and the last end has to go down. And then you just kind of connect your dots in some way. Again, it might not exactly look like that, but we're just sketching the polynomial. We have these points, we know that's where they are, and we know the ends, one has to go up and one has to go down. Okay, and that's as simple as it is for graphing. So again, anytime we have to draw a graph, obviously you can use Desmos to help you out, but you have to make sure you are plotting the correct points and you're not just kind of freehanding it, especially if I give you a graph for that. Okay, so again, there's just a few examples. We'll go through a bunch together in class. Now, the very last thing is now utilizing everything we've known. We know intervals, we know x-intercepts, we know increasing and decreasing. We're pulling that all together now to sketch a graph. All right, so you're going to be given some baseline information to make a rough sketch by hand. And then from your rough sketch, you're going to be able to determine whether the original function was odd or even. So is the leading coefficient odd or even? Oh, sorry, the degree is odd or even. And if the leading coefficient is positive or negative. Okay, and again, that'll all be based upon the end behavior of the graph. So the information that you're going to be given is where the area is increasing and decreasing, as well as where the function is positive and negative. All right. You're going to see some might be given to you in interval notation. Some might be given to you in inequality form. I know we're used to writing in interval notation, but they mean the same thing, and I'll show you how to rewrite them into what you're used to seeing. Again, increasing and decreasing. The values they give you for increasing and decreasing are going to be known as turning points. They're your local max and min. All right, that is where your function is going to be changing directions. Again, think of it like with your quadratic. We know it went up to a maximum and then down, or it went down to a minimum and then up. We know it turned at those vertices. So your increasing and decreasing is going to give you values that's going to help you know when you're changing directions. The positive or negative, those values are your x-intercepts. And they're going to tell you where is the function above the x-axis and where is it below the x-axis. Now, my next slide is going to be a lot of information, and it's going to look intimidating, but it's my entire thought process going through it. So first off, this is the final answer. This is what we end up getting to. But this is what's given. So they tell us that f is increasing when x is less than 0 and when x is greater than 4, and f is decreasing when 0 less than x less than 4. We know f of x is greater than 0 when negative 2 less than x less than 3 and x is greater than 5. And we know f of x is less than 0 when x is less than negative 2 and 3 less than x less than 5. So people look at that, they get really scared. It's a lot of stuff and just a lot of random numbers. So here's how we break it down. Increasing and decreasing. That is my moving upwards, increasing, and moving downwards, decreasing. Those are our turning points. That's where we're going to have some form of axis of symmetry. So all I did was I took the numbers, and notice the numbers repeat, 0, 4, 0, 4. They're going to have the same. Increasing and decreasing are going to have the same values, as will positives and negative. We'll get to that in a second. So I know at x equals 0 and x equals 4, I'm just going to make note that there's going to be some axis of symmetry, quote unquote, because it's not necessarily that, but it's an axis of a turning point. So you can see on my graph, there's my x is 0, there's my x equals 4. Now underneath that, when f of x is greater than 0, that just means it's positive. It is above your x-axis. When f of x is less than 0, it's negative. It's below the x-axis. Again, those are your x-intercepts. So each of these numbers, negative 2, 3, and 5, and like I said, you see them repeating on the negative part too. Those are ordered pairs. Those are your x-intercepts. Negative 2, 0, 3, 0, 5, 0. And I plotted them on the graph. Now to figure out the black line, to kind of give me the flow or sketch of the graph, I have to use this whole thought process. Okay, and it's using those intervals that they told us. So x is less than 0 just means that it goes from 0 to everything less than that. So it's 0 to negative infinity. X is greater than 4 means it's everything above it. It goes from 4 to positive infinity. That's how we're used to seeing those. That's where the graph is moving upwards. They told me that's where it's increasing. It is decreasing from 0 less than x less than 4. All that means is between. X is between those numbers. And I can see it written here. X is between 0 and 4. That's when the graph is moving downwards. So this is what I imagine in my head. From negative infinity to 0, it's going up. They told me that here. Between 0 and 4, it's going down. That's this part here. And then from 4 to positive infinity, it's moving up. Again, that was this part here. So I know it kind of follows this flow, up, down, up. Again, all imagining in my head. Then in the blue part, again, that's my above and below the x-axis. So I just take the intervals and I talk my way through it again. X is between -2 and 3. That's how the interval is written. X is greater than 5. So that tells me it goes from 5 to positive infinity. That is where the graph is positive. It is above the x-axis. X is less than -2, so negative infinity to +2, or -2, I'm sorry. And then 3 less than x less than 5, so again, x is in between those. That's where it's negative. It is below the x-axis. So in this part, I'm imagining I have an x-axis, and I have to take note of where are all these things happening. So from negative infinity to -2, I'm negative. I'm underneath it somewhere. Between -2 and 3, I'm above it. Okay. Between 3 and 5, I'm below it. So somewhere underneath. And then from 5 to the positive infinities, I'm above it. And notice it kind of oscillates down, and up. That's what should happen. You should not have a down, up, down. They should be alternating. Same thing up here. I went up, down, up. Once I have these two things imagined in my head, I can get the flow of my graph. I know on the negative infinity side, I am both going in an upward motion and I'm starting underneath my x-axis. So that's here. I continue up, I hit -2, and then I end up being positive. Oops, sorry. I end up being positive. I'm in the positive range. Once I hit that axis, I change directions. Now I'm going downward. I'm still positive because I still have to be positive between -2 and a +3. Okay, I'm going down, down, down. I hit +3. Then I have to go into the negatives. That's what I have here. So I'm in the negatives again till I hit that dashed line. Then I got to turn around again. And then up until 5 is when I should be in the positive range. So having your intercepts plotted, having your axes drawn, as you trace this, when you hit certain things, you should know what's happening. When I hit an x-intercept, I know I'm changing from positive to negative or negative to positive. I'm changing the sign. When I hit a axis of symmetry, I know I got to turn around. Whatever direction I'm going in, I got to turn it and change it. And then you just keep flowing to the next either intercept or axis, and you keep moving your way through it. So I know this is a degree that's odd because I have opposite ends. One was towards the negatives, one's towards the positives. And I know it's positive because of the fact that it's actually moving in an upward motion from the left to the right. I started in the negatives, I end in the positives. Okay, so again, this is my final answer. You do not have to write all of this out. I will write it out each time we do these just to help people who need to see all of that. But some people can go right in their heads to this part right here, and that is great. We will continue doing a bunch of these problems together to help you out with sketching the graph.